Welcome to Team Paya-Math, kung saan tuturuan ko kayo pagyamanin pa ang iyong mga nalalaman tungkol sa math. For our topic for today, let's have this video!
Hi guys, so for today we're going to discuss about combination. But before we go to the different problems or examples about combination, let's first discuss the definition and the formula for the combination. So combination, we define combination as the arrangement of n objects without repetition and the order is not important. Okay, so we emphasize or we give emphasis on the order is not important. Unlike in the permutation wherein we consider the ordering or the position of the objects that we are arranging, here in combination, order is not important. We can also define it like this. So we can have this definition for the combination, which is it is a selection of R objects from a total of n number of objects without regard to order. So any definitions will do. So it's either you will consider the first one or the second one. They mean the same. So you need to take note of our keywords for this. Combination, it is arrangement of n objects where order is not important. And we have this as our formula in finding for the number of combinations of n objects taken R objects at a time. So we have this formula here. So that is the combination of n taken R. So we can have this notation or we can use this one. Okay, any notation will do as long as for the first notation, n and r are both subscripts. Okay, and for the second notation, combination or combination of n taken r, or in this case, n followed by r. And these are all equal to this formula here, wherein we have n factorial over the quantity n minus r factorial r factorial. We need to take note that the value of n should be a non-negative integer or counting numbers, and r should be from 0 to n. Let's have now the different examples about combination.
So let us now solve some problems about combination. Let's start with the first one. We are given the combination of 7 taken 4. So for us to evaluate this, we're going to use the formula for the combination, which is n factorial over the quantity n minus r factorial r factorial. So in this case, our n is 7, our r is equal to 4. Then to evaluate or to simplify this one, this is just equal to 7 factorial over the quantity 7 minus 4 factorial, 4 factorial. We simplify this, then we will have 7 factorial over 3 factorial, 4 factorial. We further simplify this by expanding the numerator as 7 times 6 times 5 times 4 factorial all over 3 factorial, 4 factorial. And here, we can cancel 4 factorial on the numerator and we cancel 4 factorial on the denominator. We can also cancel 3 factorial and 6 since 3 factorial is just equal to 6. Therefore, we will left with 7 times 5, which will give us the answer of 35. Okay, so moving on to the next item that we have. So for letter B, we are given the combination of 12 taken 9. So same thing with the previous item. So we were going to simplify this using the formula for the combination. So this is equal to 12 factorial over the quantity 12 minus 9 factorial, 9 factorial. Then we will have 12 factorial all over 3 factorial, 9 factorial. We simplify this further by expanding 12 factorial on the numerator as 12 times 11 times 10 times 9 factorial all over 3 factorial times 9 factorial. Here we can cancel 9 factorial and 9 factorial. I can also cancel 3 factorial and 12. since 3 factorial is equal to 6, and the factors of 12 are 6 and 2, so meaning we will have here 2. Then we will left with 2 times 11 times 10, which will give us our answer of 220. So last item for this, for the first problem that we have, let's have letter C. So we are given the combination of 10 taken 5. So the value of this is equal to 10 factorial over quantity 10 minus 5 factorial, 5 factorial. This is equal to 10 factorial over 5 factorial, 5 factorial. Then we further simplify this by expanding the numerator as 10 times 9 times 8 times 7 times 6 times 5 factorial. All over, I will expand 5 factorial here as 5 times 4 times 3 times 2 times 1, and I will leave the other 5 factorial as is. Then we can cancel 5 factorial on the numerator and 5 factorial on the denominator. We can also cancel 5 and 10. Then we will have here 2. We can cancel 2 and 2. So on the numerator, we have 9 times 8 times 7 times 6. On the denominator, we have your 4 times 3. We can also cancel 3 and 9. We will have here 3. And then 4, we can cancel 4 and 8. Then 8 will become 2. Okay? So we were left with 3 times 2 times 7 times 6, which will give us 252. And this will be our answer for the third item. So let's have now the second item or the second question. Here we need to find the value of n or r from each of the following. So let's have the first item. So in letter A, we are given the combination of n taken 3 is equal to 220. So we must look for the value of n that will make this statement true. So how are we going to find for that? The first thing that we need to do is we need to simplify the combination of n taken 3. So using the formula for the combination, this is just equal to n factorial over the quantity n minus 3 factorial, 3 factorial. And this is equal to 220. Now, the next thing that I will do is I will cross multiply this 3 factorial to 220. Then, I will have now n factorial over the quantity n minus 3 factorial equals 220 times 3 factorial. Then, the next thing that I will do is I'm going to simplify n factorial over n minus 3 factorial by expanding n factorial in our numerator as n times quantity n minus 1 times n minus 2 times the quantity n minus 3 factorial. All over, we'll just copy the denominator, which is the quantity n minus 3 factorial. And this is equal to, since 3 factorial is equal to 6, then multiply to 220, we will have here 1,320. Then as you can see, we can cancel quantity n minus 3 factorial from the numerator and then from the denominator. Then we will left with n times n minus 1 times the quantity n minus 2, and this is equal to 1,320. Now, if we're going to simplify this, this will give us n times, this will give us n squared minus 3n plus 2 is equal to 1,320. We further simplify this, then we will have the cubic equation n cubed minus 3n squared plus 2n Then I will move the 1,320 to the left side of the equation. Then we will have this cubic equation. Now, since you already know how to find for the zeros of higher degree polynomial equations, so you may use different theorems that you know. You may use rational root or any other theorem that you know that is appropriate for this given. So in this case, what I would do is, of course, I'm going to consider the constant term, which is 1,320, and identify the factors of 1,320. So 1,320 has a factor of 10 times 132. We can further simplify 132. This is equal to 10 times 12 times 11. Since 132 has a factors of 12 and 11. So we're going to try these three factors of 1,320, and let's check whether one of this is the value of n. So let us now try if 10 or 12 or 11 is the value for n. So we take first 10 to be the value of n, and let's check whether this satisfies the given cubic equation. So if n is equal to 10, then we will have here 10 cubed minus 3 times the quantity 10 squared plus 2 times the quantity 10 squared minus 1,320. And this is equal to negative 600, which is not equal to 0. So meaning n is not equal to 10, or 10 is not the value that we are looking for. Let's proceed now to n equals 12. So if n is equal to 12, then we will have here 12 cubed minus 3 times the quantity 12 squared plus 2 times 12 squared minus 1,320. Let's check the value of this. If we're going to simplify this one, and this will give us 0. Since this is equal to 0, that means the value of n that we're looking for is 12. So let us now solve the second item for question number 2. In letter B, we are given with the combination of 12 taken R is equal to 66. Just like the previous item, here we need to find for the value of R, which will make the statement or the given equation true. So we first simplify the combination of 12 taken R, and this is equal to 12 factorial over the quantity 12 minus R factorial is equal to 66. The next thing that we will do after simplifying the combination of 12 taken R is we're going to cross multiply so that we will have 12 factorial over 66 is equal to the quantity 12 minus R factorial. Then we can now simplify the left side of the equation, which is 12 factorial over 66, by expanding 12 factorial as 12 times 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, divided by the factors of 66, which are 11 times 6. And again, this is equal to the quantity 12 minus R factorial. Let's simplify now the left side. We can cancel 11 and 11 on the numerator and denominator. We can also cancel 6 and 12, making 12 equal to 2. So on the left side, as you can see, we only have 2 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, which we can rewrite into factorial notation. Since we have here 10 times 9 up to 1, then this is just equivalent to 10 factorial. And then the 2 here, we can rewrite that into factorial notation as 2 factorial, since as we all know, if we're going to simplify 2 factorial, that is just equal to 2. So basically, the left side can be simplified into 2 factorial, 10 factorial. And again, this is equal to the right side, which is 12 minus r factorial, r factorial. And since we need to find for the value of r, what we could do is we can equate r factorial to either 2 factorial or 10 factorial. So we can equate r factorial to 2 factorial. If we're going to equate 2 factorial r factorial, then we will have here r, which is equal to 2. If r is equal to 2, then on the right side of our equation, we will have here 12 minus 2 factorial, 2 factorial, which can be simplified as 10 factorial, 2 factorial, which is the same as the left side of our equation. And also, we can equate r factorial to 10 factorial. If we're going to equate r factorial to 10 factorial, then we will have the value of r, which is equal to 10. If r is equal to 10, then on the right side of the equation, we will have 12 minus 10 quantity factorial times 10 factorial, which is equivalent to 2 factorial, 10 factorial, which is the same as the expression on the right side of our equation. So this means that we have two values for r, and those are r is equal to 2 and r is equal to 10. So let's have now our next problem, and this will be our third problem. And the problem is how many committees of 4 persons can be chosen from a group of 10 persons. So this problem is about combination, since what we're going to do is we're just going to choose 4 persons from this 10 persons. Okay? So our solution now would be the combination of 10 taken 4. And if we're going to simplify this, this will give us 10 factorial over 10 minus 4 factorial, 4 factorial, which can be simplified as 10 factorial over 6 factorial, 4 factorial, and will give us the exact value of 210. So meaning there are 210 committees with 4 members or 4 persons that can be chosen from a group of 10 persons. Okay, so let's have now our next problem, and this will be our fourth problem. So the problem is, in how many ways can a committee of 5 persons be chosen from 7 single ladies and 9 gentlemen? Then we have here 3 questions or sub-questions. First, if there is no restriction on the gender. Okay, so this is somewhat similar to our previous question, which is forming a committee. But here, for the first item, it says here that there is no restriction on the gender. So since there is no set restriction for the gender, then that means we're just going to combine the number of single ladies and the number of gentlemen, meaning we're just going to count how many persons are there in the group. So all in all, we have 7 plus 9, which is 16. Then that means from those 16 persons, we're just going to choose 5 persons for the members of our committee. So that is, we now have the combination of 16 taken 5 persons at a time. That if we're going to simplify, this is just equal to 16 factorial all over 11 factorial, 5 factorial, which will give us the exact value of 4,368. So let us now consider the next item or the next letter, which is letter B. If there must be 3 single ladies and 2 gentlemen. Okay? So we still have the same problem wherein we need to find for the number of ways we can form a committee of 5 persons from 7 single ladies and 9 gentlemen. But in this case, for letter B, there must be 3 single ladies and 2 gentlemen. So the first thing that we need to do is to get these 3 single ladies, then we must choose this among the given number of single ladies in the group. Since there are 7 single ladies from the group and we must only choose 3 among those 7 single ladies, then that means we will have the combination of 7 taken 3, and we need to include 2 gentlemen, and of course, to be sure that the gentlemen will be chosen from the gentlemen in the group, then that means we must have here 9, which is the total number of gentlemen in the group. So the combination of 9 taken 2, since we're just going to have here 2 gentlemen. And then, so since these two will compose the committee, then according to the fundamental principle of counting or the multiplication rule, we're going to multiply the number of ways for each conditions. Okay? So simplifying this now, we will have here 7 factorial over 4 factorial times 3 factorial. Multiply this to 9 factorial over 7 factorial 2 factorial. We can cancel 7 factorial and 7 factorial. And then if we're going to simplify this, we will have our answer, which is 1,260 committees. So let us now have the third item for this question. So the third problem is, in how many ways can a committee of 5 persons be chosen from 7 single ladies and 9 gentlemen if letter C, if all are single ladies? So since the restriction is for the 5 persons to be all single ladies, that means we need to choose these 5 persons from the 7 single ladies that we have. So our solution now for letter C would be the combination of 7, since we have here 7 single ladies, and then we're going to choose all the 5 persons or all the members of the committee from these 7 single ladies. So that's why we have here 5. Then simplifying this, we will have 7 factorial over 5 factorial 2 factorial, which will give us 21. So we're done with our question number 4. Now let's go to our question number 5. So for question number 5, we have the problem: if there are 6 red balls, 5 green balls, and 3 blue balls, and 3 balls are chosen at random, in how many ways you can get, for letter A, balls of different colors? So meaning, from since we're getting 3 balls at random, so in how many ways in these 3 balls we can get 1 red, 1 green, and 1 blue ball? Okay, so for letter A, what we're going to do, since there are 3 different colors, then we're just going to choose 1 from each colors so that we will have all 3 balls, okay, that we want to get from the given. So our solution now for letter A, balls of different colors, then we will have here the combination of 6 taken 1. So meaning we're just going to get 1 from the 6 red balls. And then we multiply this to the combination of 5 taken 1 for us to be sure that we will have 1 green ball. So we're just going to choose it from 5. And then for the last color, which is blue, we will have the combination of 3 taken 1. Okay? So we now simplify this. Then we will have here 6 factorial over 5 factorial, 1 factorial. Multiply this to 5 factorial times 4 factorial, 1 factorial, times 3 factorial over 2 factorial, 1 factorial. That if we're going to simplify, we will have our answer, which is 90. So there are 90 ways we can get balls of different colors. So we're done with letter A. Now we proceed to letter B. So in how many ways we can get 2 blue balls and 1 green ball? So in letter B, the problem specifies that in this the composition of these 3 balls is 2 blue balls and 1 red ball. So meaning we're just going to choose from the total number of blue and the red balls. Okay? So since we have 3 blue balls, so that would be combination of 3 taken 2. Okay? We multiply these 2. So since there are 6 red balls and we're just going to get 1, so that will be equal to the combination of 6 taken 1. So this is equal to 3 factorial over 1 factorial 2 factorial times 6 factorial over 5 factorial 1 factorial, which we can further simplify to 18. So we're done with letter B. Now, let's move on to the third or the last question or problem for problem number 5. So in how many ways you can get balls of same color? So in this case, for the third case, all 3 balls should have the same color. And how many ways we can get 3 balls with the same color? Okay? So since we have here 3 different colors, then we can separate this into 3 cases. For case number 1, this is the case wherein all balls are colored red. Okay? So if all balls are colored red, then that means we're just going to choose all the 3 balls from the 6 red balls. So that would be the combination of 6 taken 3. Next, for our second case, this is the case wherein we're going to choose those 3 balls from the given green balls. So since we have 5 green balls, then that would be the combination of 5 taken 3. And then for the third case, or case number 3, this is the case wherein we're going to choose all the balls from the given blue balls. Okay? So that would be the combination of 3, since we only have here 3 blue, and then taken 3 balls at a time. Okay? Since we need to get 3 balls. Now, what we're going to do with these cases is we're going to add all of these cases. Since the case 1, this is the case for the number of ways you can get red, 3 red balls. And then the second case would be the case wherein you can get 3 green balls. And then the third case is the case wherein you'll get 3 blue balls. Okay? So all in all, this is the number of ways you can get balls of the same colors. So if you're going to add all of this will give us the answer, which is 31. So there are 31 ways we can get the balls of the same color. So for our next problem, let us consider this problem. From a deck of 52 playing cards, 5 cards are to be drawn. Okay, so if you're not familiar with the playing cards or deck of cards, I have here the composition of the standard deck of playing cards. So all in all, we have 52 playing cards. So these 42 playing cards are composed of 4 different suits. So we have the clubs, we have the hearts, we have the spade, and we have the diamonds. Okay, so we can also divide this 52 in terms of their colors. So there are 26, meaning half of the playing cards are black and the other half are red. And each suits are composed of 1 ace. Then we have all the numbered cards from 2 to 10. And we have the face cards, which are the jack, queen, and king. So all in all, we have here 52 playing cards. Okay? So let's now answer letter A of this problem. So from a deck of 52 playing cards, 5 cards are to be drawn. For letter A, how many 5-card hands are possible? So meaning there's no restrictions given to us for the first problem, and that is we're just basically going to choose 5 or any 5 cards from the 52 playing cards that we have. So for our solution, that would be the combination of 52 taken 5, which is equal to 52 factorial over 47 factorial 5 factorial, which is equal to 2,598,960. So these are all the number of ways we can get 5 cards from 52 playing cards. So let us now answer letter B of this problem. So for letter B, the question is how many 5-card hands are there consisting of all black cards? So again, the composition of the 52 playing cards that we have, these are composed of 26 black cards and 26 red cards. So in this case, for letter B, we're just going to choose these 5 cards from those black cards, which is all in all, we have here 26 black cards. So to answer letter B, then our solution should be the combination of 26, since half of the 52 playing cards are black. So combination of 26 taken 5 at a time. So if you're going to simplify this one, this will give us 26 factorial over 21 factorial 5 factorial. That if we're going to simplify, we will have the value which is 65,780 cards. So now let's go to the third problem or third item, which is letter C. So for letter C, the question is how many 5-card hands are there consisting of 2 aces and 3 jacks? Okay, so again, this is the composition of our standard deck of playing cards, our 52 playing cards. So for letter C, the 5 cards should be composed of 2 aces and 3 jacks. So all in all, we have here 4 aces. Okay, so we have the ace of clubs, we have the ace of hearts, we have the ace of diamonds, we have the ace of spades. So all in all, we have 4 aces. So what we're going to do is we're just going to choose 2 aces from those 4. So that will be the combination of 4 taken 2. Then for the jacks, all in all, we have here, since we have 4 different suits and each suits has a jack, all in all, we have 4 jacks here. What we're going to do is we're just going to choose 3 from those 4 jack cards, no? So that will now be the combination of 4 taken 3. And again, according to the multiplication rule, we're going to multiply these cases here. Okay? So that if we're going to simplify, this is equal to 4 factorial over 2 factorial, 2 factorial times 4 factorial, 1 factorial times 3 factorial. Then if we further simplify this, this will give us 24. That means there are 24 ways we can have 5 card hands that are consist of 2 aces and 3 jacks. So for the last question or item for this problem, we consider letter D. How many 5-card hands are there consisting of 3 face cards, 1 king, and 1 spade? Okay, so again, the standard deck of 52 playing cards is composed of, we have what we call the face cards or the jack, queen, and king, and each suit has 3 face cards. So all in all, we have 12 face cards. So what is required for us is, for letter D, we're just going to choose 3 face cards from these 12 face cards. So we now have the combination of 12 taken 3. We're going to multiply this 2. So the next condition is for one of the cards to be a king. So all in all, we have here 4 different kings, right? So that means we're just going to have the combination of 4 taken 1. We're just going to choose one king among 4 kings that we have. Then we're going to multiply this to the number of ways we can get one spade. So how many spade cards do we have? We have 13 spade cards. Okay, so that means we're just going to choose one from those 13 cards. So that would be the combination of 13 taken 1. That if we're going to simplify this, we will have 12 factorial over 9 factorial times 3 factorial times 4 factorial over 3 factorial times 13 factorial over 12 factorial. Okay, that is, if we're going to simplify this further, we will have our answer, which is 11,440. So moving on now to our next problem. So let us consider this. So we can also apply combinations in finding for the total number of diagonals that can be drawn in a polygon. Okay, so in this case, let's consider this problem. Find the total number of diagonals that can be drawn in an octagon. So I know that you already know the formula in finding for the total number of diagonals, but in this case, let me teach you on how to use the concept of combination in finding for the total number of diagonals in an octagon. So since octagon has 8 sides, meaning it has also 8 vertices, and we define diagonal as the segment joining the two non-consecutive vertices of a polygon. So that means from 8 vertices, since octagon has 8 vertices, we're just going to choose 2 vertices. Okay? So this will now be our solution. Again, we will have the combination of 8 taken 2. 8 because we have 8 vertices, and 2 because for us to have a diagonal, we should have 2 vertices. Then after that, since we get 2 vertices, okay? Since we get 2 vertices from 8 vertices that we have, that means there's the case wherein the 2 vertices that we can get are consecutive, okay? Or magkasunod, okay? But the definition of diagonals is a segment joining two non-consecutive. So that means we need to subtract the number of sides, because if we're going to consider the combination of 8 taken 2, that means we're also counting the sides of the octagon. Since we're just looking for the number of the diagonals, that means we're going to subtract the number of sides of an octagon, which is 8. So this is now equal to 8 factorial over 6 factorial 2 factorial minus 8, which will give us the answer of 20 diagonals. Okay? So here's a proof that we have 20 diagonals in an octagon. So as you can see here, one vertex is connected to 5 vertices. Okay? So in general, if you have a question like this wherein you're being asked to find for the total number of diagonals that can be drawn in a polygon, so the formula that you're just going to use is the combination of n taken 2 minus n, where n is the number of vertices or sides. Okay? So in general, we're going to use this formula, okay, in finding for the total number of diagonals that can be drawn in a polygon. So let's say you're being asked to find for the hexagon. So find the total number of hexagon. Find the total number of diagonals in a hexagon. So we're just going to take n, which is equal to 6. So you'll now have 6 combination of 2 minus 6. And this will give you 9. So we could also apply the concept of combination not only to the number of diagonals, but also to the number of polygons that we can make out of the non-collinear points in a plane. So let's have this, or let's consider this problem. How many triangles can be drawn on a plane using 4 non-collinear points? Okay, non-collinear meaning these 4 points do not lie on the same line. Okay, so how many different triangles that we can form using 4 non-collinear points? So as we all know, for us to have a triangle, that means we need to have 3 points. Okay, so from 4 collinear points that are on the same plane, we're just basically going to get or choose 3. Okay, so our solution now is combination of 4 taken 3, that if we're going to simplify, we will have 4 factorial over 1 factorial, 3 factorial. Okay, so this is equal to 4. That means we can have, or we can draw 4 triangles using these 4 non-collinear points. So before I go to our last problem about combination, if you have reached this point of the video, please comment on the chat box below, Paya-Math. So let's have now our last problem about combination. So let's consider this problem. Norman has 6 friends. How many ways can he invite one or more of them to dinner? Okay, so we need to analyze this, that in the problem it says here that he can invite one or more of them. So that means from 6 friends that he has, he can invite 1, he can invite 2, he can invite 3, or he can invite all of his friends. So meaning we will have here 6 cases. Okay, so we have the case 1 wherein he invite 1 friend. So that means we will have the combination of 6 taken 1. Okay, so this is equal to 6 factorial over 5 factorial, which is just equal to 6. Okay, now for our case 2, this is the case wherein he can invite 2 of his friends. Okay, so we will now have our solution, which is the combination of 6 taken 2, which is equal to 6 factorial over 4 factorial, 2 factorial, which is just equal to 15. And then for case number 3, this is the case wherein he will invite 3 of his friends. So our solution now would be the combination of 6 taken 3, which is equivalent to 6 factorial over 3 factorial, 3 factorial, which is equal to 20. Okay? Now for the next case, case number 4, this is the case wherein he will invite 4 of his friends. So we'll now have the combination of 6 taken 4, and this is just equal to 6 factorial over 2 factorial, 4 factorial, which is equivalent to 15. And then for the case 5, this is the case wherein he will invite 5 of his friends. So that will be the combination of 6 taken 5, which is equivalent to 6 factorial over 5 factorial, which is equal to 6. And lastly, the case wherein he will invite all of his friends, or 6 friends. That would be the combination of 6 taken 6, which is equivalent to 6 factorial over 6 factorial, which is equivalent to 1. Then, since all of these cases are different from each other, what we're going to do is just simply going to add all of the ways for every cases. So we'll have your 6 plus 15 plus 20 plus 15 plus 6 plus 1 which will give us 63. Okay? So, to make this solution short, I will introduce to you this concept of combination. This is the concept wherein you have or you're going to find for the number of combinations of n objects taken one or more at a time. Okay? So which is given to us by this formula, which is 2 raised to n minus 1. That if we're going to apply it here in this problem, our n is equal to 6 since Norma has 6 friends. Okay? So the total number of ways he can invite one or more of his friends to the dinner is equal to 2 raised to 6 minus 1, which is equivalent to 64 minus 1, which is 63. So either way will work as long as your solutions and your formula are correct.
Thank you for watching! Don't forget to click the notification bell and subscribe button para updated ka sa mga videos ko.